Hey, welcome to my channel Technologies in Industry 4.0. In this video we will discuss about microprocessor evolution in types and working. So, let's start the video.
Microprocessors evolution. Introduction. The microprocessor is a CPU that built on a single integrated circuit, IC. It is a necessary component of the computer. It is a silicon chip that includes millions of transistors and many other electronic components that process millions of commands per second. A microprocessor is a multipurpose chip that is joint with memory. It receives digital data as input and processes it, allowing to the commands stored in the memory. The microprocessor has several functions similar to functions of data storage, relate with many other devices, and several other time-related functions. The key function of a microprocessor is to send and receive the data to make the function of the computer in good health. In this article, we will discuss the types and evolution of microprocessor. Description. What is microprocessor? The microprocessor comprises millions of small components similar to transistors, registers, and diodes that work organized. A microprocessor contains an ALU. It executes arithmetic and logical operations on the data received from an input device or memory. Control unit. It handles the instructions and flow of data inside the computer. Register array. It contains of registers recognized by letters like B, C, D, E, H, L, and accumulator. Evolution of microprocessors. We may classify the microprocessor according to the generations and the size of the microprocessor. First generation. The first generation microprocessors were presented in the year 1971 to 1972 by Intel Corporation. The commands of these microprocessors were processed serially. They made the instruction, decoded and then executed it. The microprocessor updates the instruction pointer and made the following instruction, acting this repeated operation for each instruction in turn when an instruction of the microprocessor was finished. Intel manufactured the first IC microprocessor in 1971 named 4004 due to 4-bit processor and having 2300 transistors. It was included a processor on a single chip. It could make simple arithmetic and logical operations, for example addition, subtraction, and Boolean. Second generation. The second generation microprocessors were presented in 1973 for a second time by Intel. It was a first 8-bit microprocessor that could execute arithmetic and logic operations on 8-bit words. The second generation of the microprocessor is well defined by overlapped fetch, decode, and perform the steps. When the first generation is processed in the execution unit, then the second instruction is decoded and the third instruction is fetched. Third generation. The third generation microprocessors were presented in 1978 by Intel's 8086, Zilog Z800 and 80286. Those were 16-bit processors with a performance similar to mini-computers. These types of microprocessors were changed from the earlier generations of microprocessors in that all key workstation industrialists began evolving their own ISC-based microprocessor architectures. Microprocessors evolution, types and working. Fourth generation. The fourth generation microprocessors are arrived with exceptional design with 1 million transistors. Frontline microprocessors like Motorola's 88100 and Intel's 80960CA might issue and give up work more than one instruction per clock cycle. A number of different companies familiarize the 32-bit microprocessors, however the most standard one is the Intel 80386. Fifth generation. Fifth generation microprocessors in a job decoupled superscalar processing. Their design rapidly surpassed 10 million transistors. PCs in the fifth generation are a low-margin, high-volume business occupied by a single microprocessor. We are in the fifth generation from 1995 to at the present. Intel came out after 80,856 with a new processor, namely Pentium processor. That was followed by Pentium Pro CPU that permits various CPUs in a single system to attain multiprocessing. Types of microprocessor. We can classify the microprocessors into following 5 types. Complex Instruction Set Microprocessors, CISC. Reduced Instruction Set Microprocessor, RISC. Application-Specific Integrated Circuit, ASIC. Superscalar Processors. Digital Signal Microprocessors, DSPs. Complex Instruction Set Microprocessors, CISC. The Complex Instruction Set Microprocessors is CISM categorize a microprocessor in which orders may be done together along with other low-level activities. These types of processors implement different tasks similar to downloading, uploading, and recalling data into the memory card. Apart from these tasks, it also does complex mathematical calculations in a single command. Reduced Instruction Set Microprocessor, RISC. These types of microprocessors are prepared consistent with the function in which the microprocessor may do small things in particular commands. This way, these processors complete more commands at a more rapidly rate. The Application-Specific Integrated Circuit, ASIC. These types of processors are used for specific drives that comprise automotive emissions control or personal digital assistance computer. These types of processor is made with the good specification and can also be made with off-the-shelf gears. Superscalar microprocessors. Superscalar processor copies the hardware on the processor to do many tasks at a time. These processors may be used for ALUs or multipliers. They have changed operational units, and these processors can do more than one command by non-stop transmitting numerous instructions to the extra operational units inside the processor. Digital Signal Multiprocessors, DSPs. These processors are used to encode and decode the videos. Also used to change the digital to analog and analog to digital. They require a microprocessor that is outstanding in mathematical calculations. The chips of this processor are working in radar, home theaters, sonar, audio gears, TV set-top boxes, mobile phones. Microprocessor working. Microprocessor follows the below steps for working. Fetch. The commands are in storage from where the processor fetches them. Decode. It then decodes the order to allocate the task further. The arithmetic and logic unit also completes to register the data provisionally for the duration of this. Execute. The assigned tasks undergo execution and reach the output port in binary form. Pros and cons of microprocessors. The pros of microprocessors are: very high processing speed, compressed size, easy maintenance, can do difficult mathematics, flexible. Microprocessors' disadvantages are: overheating takes place due to overuse. Act be determined by the size of the data. Huge board size than microcontrollers. Maximum microprocessors do not support floating point operation.